I have selected the more important geometry theorems and postulates to solve most, if not all, of the geometry problems. So, number 1, if the perpendicular distance between the two lines are equal, the two lines are parallel. So this symbol, these two small lines, signifies that these two lines are of the same length, and these are two perpendicular lines on this line. If these two lines are the same length, then line AB and line CD are parallel. Number 2, two supplementary angles form a straight line. For example, if we have a straight line and then a line passed through in between these two lines, the angle A and angle B would be equal to 180 degrees. For example, if A is, let's say, 70 degrees, B would be 180 minus 70 degrees, so B would be 110 degrees. Now, number 3, vertical angles are equal. So if you have two intersecting lines, the opposite angles are equal. So if, for example, this is let's say this is 50 degrees, so the angle opposite is also 50 degrees. Now this is a straight line, so we can solve for this one. 180 minus 50, so this is 130 degrees. So the angle opposite that is also 130 degrees. Now, number 4, alternate interior angles are equal. So if you have two parallel lines, and this is called a transversal, a line passing through the two lines, the interior angles are the angles inside the two parallel lines. So your interior angles will be here, 1, 2, 3, and 4. The interior angles, the alternate interior angles will be one on the left and one on the right of the transversal. So if this is the first angle, the alternate interior angle is this one. This will be equal. For example, this is, let's say 70 again. This would also be 70. Now, we can get this one because this is a straight line, we can get 180 minus 70, this is 110 degrees. So the alternate angle for this one will be this one. This would also be 110 degrees. Alternate exterior angles are equal. So exterior angles are angles outside the two parallel lines. So this would be this 1, 2, 3, and 4. These are all the exterior angles. So alternate means on each side of the transversal. So if, for example, this is your exterior angle, the alternate one for that one will be this one. So these two are equal. Let's say this is 120 degrees. This is also 120 degrees. So this one is a straight line, so we can solve for this one. 180 minus 120, this is 60 degrees. So the alternate angle for this exterior angle is this one. This is also 60 degrees. Now, same side interior angles are supplementary. Means if you add them, it's equal to 180. So same side interior angles, so these are your interior angles, 1, 2, 3, 4. Same side, it means same side of the transversal. So this one plus this one would be 180. For example, if this is, let's say this is 120, this would be 180 minus 120, this is 60 degrees. Now, so this is 60. To make this into a straight line, this will be 120 degrees. 180 minus 60 is 120. So if this is 120, this would be supplementary to this one, so this would be 60 degrees. Number 7. The total internal angles of any triangle is always 180. So for example, this is 70 degrees, this is 60 degrees. The third angle will be 180 minus 70 minus 60 degrees. So that would be 50 degrees. So x will be 50 degrees to have a total of 180 degrees. Number 8, the base angle of an isosceles triangle are always equal. For example, we have an isosceles triangle, so this line is the same length as that line, and if we know one angle is 30, then the other angle will also be 30. In reverse, if you have a triangle with the same angle on its sides, and you know this length is 5, then this is also 5 units. Number 5, if all the internal angles of two triangles are equal, they are similar triangles. For example, this angle ABC has an internal angle the same as triangle DEF. They are similar triangles. So what we can deduce from that, they have the same ratio. For example, line AB over line AC is equal to line DE over line DF. You can compute for the lengths using the ratios. Also, if you see a triangle that has a parallel line on one side, parallel lines, then these are similar triangles. BCD is similar to triangle ACE. So the implication of that one is they have similar ratio as well. So for example, line BC over line CD is equal to line AC over line CE. They have the same ratio, so we can solve for the lengths using the ratios. Number 10, angles in the same segment and the same chord are equal. For this example, we have 3 triangles that have the same segment and same chord. So this is the first triangle, this is the second triangle, and this is the third triangle. They have the same segment and lie on the same chord. So if, for example, if this is 55 degrees, this is also 55 degrees, this is also 55 degrees, because they lie on the same segment and the same chord. Number 11, a line from the center to the midpoint of a chord is perpendicular to the chord. For example, there's a line from the center and it intersects the chord and divide it into 2 equal segments. Then this is perpendicular or 90 degrees. So in the same way, if a chord passes through a line and is perpendicular to this line, this chord, then this line segment is equal to this line segment. Number 12, the angle at the center is twice the angle at the circumference. For example, this is the center, and there's a line protruding into the circumference, and then this one is going to the circumference. If this is 50 degrees, this is twice 50 degrees, so this is 100 degrees. Number 13, the angle between the tangent and the side of a triangle is equal to the interior opposite angle. For example, if we have a tangent line and this angle is 60 degrees, this angle, which is opposite this line segment, this would also be 63 degrees. And if this is 45 degrees, this line segment, the angle opposite that, this would also be 45 degrees. Number 14, the angle of a triangle in a semicircle is always 90 degrees. In here we have 2 triangles that the line segment lies on the semicircle. So we have 2 triangles, this one triangle and then there's another triangle. this angle will be 90 degrees. This also would be 90 degrees. Number 15, tangent lines from a circle to a common point are equal. If we have two tangent lines intersecting at a common point, the line from the point of tangency to the common point and this line from the point of tangency to the common point will be equal. These two lines will be equal. Number 16, the angle between the tangent line and the radius are always 90 degrees. So if we have another tangent line and there is a line from the center towards the point of tangency, this angle will be 90 degrees. This is also 90 degrees. Number 17, a cyclic quadrilateral is a quadrilateral where the vertices lie along the circumference of a circle. So here's an example of a cyclic quadrilateral. So the vertex, all the vertices are in the circumference. So in a cyclic quadrilateral, the opposite angles add up to 180 degrees. So for example, A plus C, if you add A plus C, the total would be 180 degrees. If you add angle B and angle D, the total would also be 180 degrees. So if you have, if this helps you in some way, you can like and subscribe.